It's biology with Mr. B. Biology with Mr. B. That's me! I've not done that theme song for ages, which is probably a really good thing. And it's not actually biology today. I am doing something that is across all three of your sciences, specifically for your exams. Let me show you if I can get rid of this. Here we go. I want to have a quick look at 5 of our science subject-specific vocabulary. The 5 that I know as a GCSE examiner, students sometimes mix up and maybe don't quite understand the small nuances between these terms. So hopefully in this very short space of time, I'm not only going to sort of present to you what each of these 5 mean, but also use my examiner brain and hopefully share with you the common thought process you should have in the exams to generate marks. So let's go. Number 1, accuracy and precision. If you go online on YouTube and you search for accuracy versus precision, you get a dartboard example every single time. And the dartboards are good, but they don't always help you get marks. So let's start with the definitions AQA give us. Accuracy is a measurement that is judged to be close to the true value. True value meaning the correct value, which in a dartboard example would be the middle bullseye. Precision has nothing to do with how accurate your results are. Precision is nothing to do with getting correct results. Precision is where all your results, so say you've done 3, 4, 5 repeats, if all of them are the same, that means you've been very precise. So precise measurements are ones in which there's very little spread about the mean value. So you've got your mean, say the mean's 16, and all your results are like 15, 16 or 17, that's really precise. But the true value could have been 10. So you can be precise, yet completely inaccurate. So just to show you with the dartboard method, I'll put the definitions back up again. So top left here, none of them are at the bullseye. You've got low accuracy. None of them near the true value. And because they're all different to each other, there's a massive spread around the mean, the average, which means you've got low precision as well. That is a scientist's version of hell if you get those results. Top right. Now we're only missing one aspect. I've managed to group the arrows, the results together. They all seem to be around the same mean. So that means we've got high precision. But now the accuracy is wrong. They are not near the true result. So if this is the case, and you were asked how to make something more accurate, your job as a student is to go back into their method, read what they have done, and find something that would have made the results more accurate. It might be that you identify and remove anomalies from your mean. Anomalies, results that don't fit the trend, are the definition of inaccurate results. So remove them from your mean, and your mean becomes more accurate as a result. It may be that maybe you're in chemistry and you're heating a beaker of water, because it's really advanced science. But if you're heating that beaker of water and you're looking to see, how much energy you put in to maybe raise it by 10 degrees, well, a more accurate experiment would maybe, instead of a glass beaker, use one maybe that had polystyrene on the outside as an insulator, or maybe had a lid to stop heat from the water radiating out to the environment. So look at their experiment. What could they have done to make their results get closer to the true value? Oh, just my biology head on. A really good one from photosynthesis, because I appreciate, certainly for combined scientists, that practical is is a green is one that is likely to come up. If you're counting bubbles in photosynthesis, well, bubbles might be different sizes, which makes it inaccurate. If you measure the volume with a gas syringe, that is sexy accurate. Bottom left. Here we have low precision because they're spread around the ball. You've got a decent spread around the mean, but you have got high accuracy because they're all roughly there. So here you are likely getting things right. You're doing the right things, measuring the correct ways. But low precision kind of indicates that maybe you're doing something slightly different each time. The most common idea here is the idea of error. And there are different ways to get error, but the one that never gets marked is if you say human error. But we all know human error exists. Humans are biased. We lack the ability to be completely random with the way we do things. So if you can replace a human idea, maybe with a computer, you're likely to increase your precision. A really nice example of that is maybe rather than looking at colour change using your eyes, which is subjective, you use it using a colorimeter, a machine that gives you a quantitative and numerical value for colour. After all, what is colour? It's just wavelengths, isn't it? Think of your electromagnetic spectrum in physics. So for precision, how to improve precision? Is there part of the experiment that you can replace with a machine or a data logger or a pH probe or something like that that gives you an answer to a greater resolution? More decimal places will certainly make things more precise. And hopefully, putting the two ideas together, you end up with results. If you're doing it yourself, you end up with results which are all perfect, all very little spread around the mean, great precision, but also great accuracy because you have the true results. Okay, next key term, validity. This is the most common term you're going to see out of the 5 in your exams. It's going to be across all 3 sciences, not even just like maybe one per paper. You might see it 2 or 3 times in the same exam. Certainly I have done in biology a couple of years ago. The examiner who wrote paper 2 just loved the term validity. And if it does come up, good. Don't need to revise for validity, not really. But we need to know what it means, otherwise you're gonna make a mess of it. Validity is, again, this is the posh definition, the suitability of the investigative procedure to answer the question being asked. It means, is it a fair test? A valid experiment is one that is fair. But we can't use the term fair test. We have to use the term valid. Best way to remember what to do to make experiments more valid is to think of where you have heard this term, maybe in a lovely, joyous song. A variable song, perhaps. So the most important part of the variable song is obviously for most students is so you always know what the independent, what the dependent variable is, and how you plot them on your graph. But the third verse is this. Control variables stay the same. Control variables stay the same. It's so you can compare, and the test you do is valid. Control variables stay the same. Because to make an experiment more valid, you need to think about your controls. Your control variables. What do you need to keep the same in order to get results that are fair or valid? So you can see this as a 2 marker, 3 marker, 4 marker, because there might be multiple control variables that their method in the exam might have forgotten. If it's an enzyme practical and they're changing the pH, that's the independent variable, if they've not mentioned anything about a water bath to keep it at a certain temperature, boom. Add that to the method, you make it more valid. Have they controlled the volume of the reactants, the concentration of the reactants? What have they forgotten to keep the same? That if they don't keep the same, could negatively impact the fairness, the validity of the experiment. And then finally, the reason why I've put here is number 2 with an exclamation mark. Although it doesn't quite fit the definition, there always seems to be a mark on offer for saying that you would do repeats and calculate a mean to make things more valid. Again, it doesn't quite fit the definition. The definition is all about control variables. But you do seem to always have access to one mark for mentioning that you will do repeats to make an experiment more valid. And lastly, the last definitions out of these 5 used to be called reliable. But for your GCSE, the term reliable does not exist. If you use it, you get no marks. The terms we have to use now are repeatable and reproducible. Your repeatable definition: a measurement is repeatable if the original experimenter repeats the investigation using the same method and obtains the same results. In other words, you've done an experiment once, following your method, your equipment. If you then so the same person, do the same experiment using the same method, same equipment, another 3 times, and you get the same result every time, boom, your results are repeatable. If you do it again 3 more times with the same method, same equipment, and you get different results every time because you're not very precise, that's not repeatable. Reproducible is very similar. The big difference is it's not you doing it, it's someone else. So it's reproducible if the investigation is repeated by another person, and it might be that they don't even use the same equipment. They might not even use the exact same method, they might change it up a little bit. But if they get the same trends, patterns as you every time, then you'd say it's reproducible. So reproducibility, it doesn't mean exactly the same results. Not really. Like if you got 16, it doesn't mean they're going to get 16, because they might have used half the volume of a reactant, so they might only get 8. But if they get the same trends, then it's reproducible. Anyway, I hope that was useful. And if that gets anyone in here an extra mark or 2 marks in their GCSEs, well, that might literally be the difference between a 7 and an 8. So a 6 and a 7, or an 8 or a 9. So here's hoping. What I'm going to ask you to do now, because it's a really good use of your time, is to access Teams. I have placed in the GCSE Biology Resources channel a document from AQA which gives you lots of examples of required practical related questions with mark schemes. So go into GCSE Biology Resources, General, Class Materials, and number 6, Skills. You'll see a couple things that are here from previous, but the one that I've put on today, well this evening, is this: required practical sample exam questions. So this is made by AQA, and there are a selection of biology, a selection of chemistry, and a selection of physics questions based on required practicals. Now these were all questions that were in the specimen papers that AQA produced in 2016. So not all of them are on topics that are in your exams. You should be well aware of those lists, or at least where to find them if you don't know it off by heart. So make sure you are, of course, only looking at practicals that are definitely on your exams. Try to focus on those that have been listed as key content. And you can choose anywhere really within here that gets your interest. I'd recommend looking at a practical that perhaps you've not revised yet. or you've not had an extra go at, or you've not looked at in a workshop. So use your time productively. Please use your time productively. You've got a massive holiday coming after these exams, so use every second you've got now. Thanks very much for your time. I hope it was useful. Cheers.